Welcome back to doing some more component work here. I'm going to add these two together, questions 2 and 3, because they're kind of doing the exact same thing. You're given a magnitude, you're given an angle, and we need to find our components. Class, this just is not going to go away this semester, or at least definitely in Unit 2. Unit 2 is going to be a lot of finding components. This is really critical, not just for the exam. You're going to have questions like this on the exam, right? But it's going to be pretty critical for, the next unit. Newton's laws, vectors, torque. It just doesn't go away. So I'm just laying that out for you. Learn how to do this. Really important. But it's logical, all right? That's the piece. There's two ways that we're going to be doing these problems. So this might be a little bit of a longer video, okay? Now, first thing I could do is I could think about drawing these. I'm going to draw. I have my vector here. I'm going to make these maybe a little bit smaller in terms of the lines. There we go. There's one vector right there. I have another vector going right here. One of those is the x component, one of those is the y component. Now the thing is when I drew this, I didn't pay much attention to my angle, right? When I draw this x and y components, yep, I can put them right this way, but my angle that I'm using is right there. If I'm going to be using this angle, I'm going to be going x and y components like so. All right, I'm going to follow the x, I'm going to follow the y components of my resultant vector, right? That r is the resultant. I'm going to get there, I'm going to decompose it into just moving the x, just moving in the y. So this is my rx component, and this is going to be my ry component right there. That's what it looks like graphically. And if we use this small angle, I'm going to adjust and add my vectors together, my rx and ry, in such a way that I'm going to include this angle right there. Because I'm going to use my right triangle rules in sine, cosine, tangent to take advantage of this. Okay, that's a right triangle. Let's just do rx. Rx, guys, this is not hard, but it just takes time. It's just tedious. It's tedious work. I understand that. So rx. Let's see, I'm going to label these. So this is my hypotenuse, this is my adjacent, this is my opposite. So Rx is related to the adjacent, which is cosine. So I get cosine of theta is equal to Rx over my hypotenuse, which is R. So if I solve for Rx, Rx is equal to cosine theta times R. There we go. All right. Now if I needed Ry, I know it seems a little too simple, doesn't it? Ry, there's my angle right there. Ry is the opposite, that's my sine theta. Sine theta is equal to opposite, that's my Ry, divided by hypotenuse, which is R. Solve for how big that Ry is. That Ry component is equal to R sine theta. There we go. Okay, so that's method one. That's using the small angle, right? I'll note that here. This is using the small angle. What do I mean, small angle theta? I'm going to erase this right here. There's another way we could do this. It can be just as slick, but it tends to maybe take a little bit longer with adding angles. You have to make sure you have your angle right to do this. So the other one I'll say is the big angle version, right? If you measure the angle of the resultant vector, the vector that you are trying to find the x and y components on, if you always measure the angle from the x-axis, right? I'll call this big angle phi, right? Then there's another way that you can calculate this, and it's always going to be the same. You'll see what I mean by that when I do the next question here. Okay, so this is my angle phi. When I do this angle phi, always the Rx component is going to equal to R cosine phi. And then my Ry component is always going to equal R sine phi. Always, 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 always. Okay? Now, Dr. Ray, doesn't that match over here? I mean, in a way, it does. Let's look at Rx. In this case, calculate the x component. Magnitude is 0. Okay, need to fix that. I'll do the y component because I don't want to have a 0, right? If the y component is 14 and I have an angle of 33. So I'm going to do number 3 here. Okay, so So at number 3, I want to calculate the y component. So ry is equal to r, magnitude, that's 14. 14 times, let's see, sine of my angle, which is 39. 39. Okay, so that's 8.81. Okay, so this is equal to 8.81, whatever meters, units it is. I do have to be a little careful though, because it looks like my ry component points down, which means I need to put a negative in here. My calculator, if you can see that, my calculator right there actually has 8.81. It doesn't have a negative in front of it. I have to put that negative in there when I use that small angle, right? Right. Positive, plus minus, have to be included, whatever you want to put after calculation, right? You have to account for it. You have to account for the positive and negative. That's probably the way I wanted to say it. Now over here, if I wanted to put numbers in, right, so ry was equal to 14 times sine of 39. Okay, now if I want to come over here, if I do this ry, I got to be a little more careful with this sine phi. I get 14 times sine. It's the angle from the x-axis. So this is 90. This is 180. So I have to take 180 plus 39. So 180 plus 39. My angle is 219. So this is 219. 180 plus 39. If I take that, 14 sine of 219, you get negative, right? It's right there on the calculator, negative 8.81, right? The negative kind of comes along this way. You have to figure out what the true angle is from the x-axis, not the negative x-axis, the positive x-axis. You have to calculate that, but it comes out and you don't have to account for the negative, but you have to make sure you account for the right angle. All right. Just going to plug that in there just so I have that right. This right here, the magnitude is 0, this is going to be 0, right? And this guy's going to be here is negative 8.81. That's what that will be. Okay. Yeah, that doesn't make sense because it can't be at magnitude 0 if it's at an angle. Anyway, I'm going to have to adjust that. Alrighty then. Clear. Well, do I want to clear? I'm not going to clear quite yet. I'm going to clear over here. I'm going to go to the next one. Sorry, this is going to be a little bit of a longer one, but I walked through this step by step for y'all. Just in case this stuff is a little difficult, because it can be. All right, now let's do the same thing. There's my Rx component, right? Now, should I draw it there or should I draw it there? Which one? Rx here, Rx there. Well, there's my angle. So I'm going to make my Rx and my Ry component kind of capture that. Oh, no, wrong one. Wrong one. I'm up here. Question 3. Come on, Professor Ray. That's question 4. Question 3. Vector below is magnitude A and an angle theta. All right. So there's my Rx. I want to enclose that angle right there. So there's my new Rx component. It's not perfect, and it just went away. Doesn't want to be the x component, but you're going to be the x component. There you go. All right. Let's see if the Ry will play along a little bit better. There we are. There's my Ry. There's my Rx. Rx, Ry. I'm just creating that triangle, and within that triangle, I'm making sure my triangle includes that angle theta that I'm given, right? You don't have to. But if I did it the other way, this angle here would be 90 minus theta, right? It's just, again, a lot of accounting, but it's very logical. It's very logical. So if we go through here, go through this, I guess it wouldn't be R anymore. It would be A. Sorry. This. So this is A, Y. This is going to be A, X. There's my angle theta. If you're working through this, great. Hopefully you're a little bit ahead of me at this point. So we have AX. AX, well, let's see, there's the angle that I have of interest, 90 degrees. This is going to be my hypotenuse. This is now my opposite. This is now my adjacent. All right. So if I want the AX, that's associated with the opposite, and I know how big my hypotenuse is. So I'm going to use sine for this. So sine of theta is equal to AX over A. So AX is equal to A sine theta. Okay. Notice before on the other one, AX was, or RX was R cosine theta. So when I use this small angle, it seems that the sine and the cosine could sometimes be for X and sometimes be for Y. Let's continue on. AY. So look at the Y. Y is adjacent, and I know the hypotenuse. That's the cosine. Cosine of theta is equal to AY over A. So AY is equal to A cosine times theta. Okay, so again, there's that same thing, same pattern, right? Sometimes AY can be associated with sine. Sometimes AY can be associated with cosine if we're using the small angle. All right. If we use the big angle, though, the Rx is always cosine phi times R. Ry is always R times sine phi. That's always true. But I have to make sure I'm using the big angle. Big angle in this case. That one right there. There's my phi. Oops, I did it again, didn't I? I'm using the wrong one. Big angle is this. There's angle phi. All right, so again, let's just kind of pick one here, calculate the x component, calculate the y component. Magnitudes and angles are changing, but I mean, you're just changing your numbers. Your values, your equations are staying exactly the same. So if I look at my x component, I'm going to take A, which is 17. I'm going to take that times sine of the angle, which is 22.9. If I do that, I get 6.61. Okay, is it positive or is it negative? It's pointing to the right, so this is going to be positive. AX is in the rightward direction, so that's plus 6.61. Now if I change this over here, I get my RX is equal to, AX is equal to A, which is 17, times cosine of phi. All right, so it looks like this is 90, this is 180, this is 270, so I have to take 270 plus 22.9 to get, 270 plus 22.9, 292.9. I should have been able to do that in my head, 292.9. 17 times cosine of 292.9 equals 6.61. Positive. Same thing. Exact same thing. Get down here. 6.61. Well done. All right. Here, might as well just check them both on the end. AY, you have 10 times cosine of 18.8. All right, I get 9.46. Is that positive or negative? Come on. 9.47. And then AY is going down, so I have to include that negative, right? Use that small angle. You have to account for that negative. Now if I come over here, it will be AY is equal to, let's see, this will be 10 times angle of 18.8. I have to use sine of something different, right? So again, different numbers. So, but it just corresponds to, hey, your vector is changing. Calculating x component if this is this and this is that. All right. So then 10 times sine of 270 plus 18.8 gets me negative 9.46. Negative 0.47, same thing. Put that in there, negative 9.47. Let's push the submit and see what it says. I know. 1 point out of 7. What's